Okay, so today I'm going to talk about how to set shelf life for a product. And, we've seen shelf life or expiration dates on various products, whether they be food products or pharmaceutical products, anything like that that actually would degrade over time. And the whole premise here is that you want to set a shelf life so that, at that time, the product is still acceptable to the consumer and user. So visualizing it in a very general way, you have some kind of degradation level. So as time goes on, the product would simply get worse and worse. And you may have a relationship describing that. Okay, so for example, here we have a idealized situation where as time goes on, the degradation gets worse and worse according to some linear model. Now you can also imagine that if you're making a bunch of products and you have maybe different types or batches or whatever, you're going to have a lot of these lines which may be altered slightly, have different characteristics. So you might have a situation like this. So you're manufacturing product and you've got different slopes or rate of change for the different batches or products. And you still want to be able to set kind of a realistic shelf life or expiration date. Well, one way to do it would be to actually aggregate these results and kind of try to define, a general model. Okay, so this dotted line represents kind of an aggregate of all these different individual, let's say, batches. And from this, we can start to think about setting our specification limit. So the first thing is to actually understand what level we're willing to accept, okay? And this takes a little bit of effort because this is based on the end user requirements. So for example, if it's a consumer, you want to set the level so that at a certain time, the product they receive is still, acceptable to them. They're not seeing really any major difference, okay? So this will take a little bit of work, a little bit of thinking to figure out what level to do this at. Some studies are probably involved. And then once you understand the level that you really desire, the next one is to actually set the time value. And this is simply a matter of, choosing the intersection of these two based on this, regression formulation. So this would be the kind of the expiration or shelf life for this product given by this linear model here. The only thing is you have to also take into account variability. So you can see that some of these products, either fail before or after the expiration date. So there's variation around this estimate. And we can kind of look at it from this standpoint. So if we set, a shelf life here, it's kind of an average value, but you notice that half the product at the shelf life will still be good, but maybe the other half will be out of compliance. So in order to accommodate that, given this variability, you would actually have to shrink that shelf life down a little bit. So instead of the mean life here, you'd actually have to move it down a little bit further here to make sure that you have the minimum amount of product out of code or out of specification given some mean level here. Now I've actually developed a little bit of a calculator here that might help with this. And let's go ahead and open that up. So this is a shelf life calculator. And again, it's based on this linear model idea. So what you have is the maximum degradation level that you would want to have at some time level. So let's say 3. In this case, the higher you go up, the worse it is. And then the weekly decay rate, so that would be the slope, okay, that you've estimated from your data. So let's say we'll just keep this value 0.052. The starting level is the intercept based on the regression model. And you may think, well, it's going to be 0 automatically at week equals 0, but that's not necessarily true. You already might have some kind of scaling characteristics or degradation at week equals 0. So you need to kind of understand your model and your product to actually understand if that's going to be true or not. And then the variability. Okay, so this is that variation for that bell curve, and this is very important to estimate as well. So you can either use the estimates from your regression model, or if you have some process estimates or some other data, you can use that as well. And then the compliance level for how much you want out of specification at the expiration date. So typically you want a smaller value, so let's say no more than 10%. And then you hit calculate, and it'll give you the shelf life in weeks, okay, 44 weeks, and then no more than 10% out still gives you about 44 weeks. A lot of this is based on this variability estimate. So for example, if your variability is very high, let's say a 2 here, you can see that you would have to reduce your shelf life by about 3 weeks, okay, to make sure that no more 10% is out. You can move this down to 1% and recalculate, and you can see that even then you have to reduce your shelf life more. If you want a little bit more, robustness in your estimates, you have to work on variability. So if we reduce this variability by 50%, recalculate, you can see that the estimated shelf life will be coming up a little bit on that lower end as well. So again, you can do a lot of what-if scenarios here. My only caution is don't extrapolate, past what your data allows you to do. So if you're, trying to set a realistic shelf life, kind of stick with the data and the model, but you can play around with these values to kind of see what affects what the most, and that's what's kind of nice about these what-if scenarios. You can change your degradation level to lower, say no more than a 1 or a 1, and recalculate, and you can see that, if you're going to have to really have a very short shelf life, you're going to have to sell very quickly and consume very quickly as well. So a lot of factors involved here, and this what-if calculator will be very helpful in determining those type of parameters you need to adjust. Hope this helps, and we'll talk to you again.